while you are using your computer typing in your keyboard, which sends signal to the CPU. That is an interrupt. What are interrupts, who inform it, and who informed by it? Interrupts are signals sent to the CPU by external devices, normally input and output devices such as mouse click. So, what happened when CPU get the signals of interruption? Signals tell the CPU to stop its current activities and execute the appropriate part of the operating system. Why interrupts are important? Because they give the user better control over the computer. Without interrupts, a user may wait for a given application to have a higher priority over the CPU to be ran. That is why interrupts are important, ensuring that the CPU will deal with the process immediately. The word interrupt does not seem appropriate for smooth communication. Hardware interrupts are a normal way for hardware and the CPU to communicate. For example, hardware components require attention and monitoring, however. Not all CPU resources are dedicated to monitoring signals from one particular hardware component. Interruption signals are sent to the CPU, and if an interrupt have higher priority than the process currently being serviced, the CPU suspends the current process, deals with the higher priority interrupt, and then resumes the original process. The keyboard may interrupt to signal the operating system that the console user has typed a character. System interrupts occurs below operating system level and is not associated with any particular process. They are a key way in which hardware interacts with the operating system. The CPU hardware has a wire called the interrupt request line to queue all interrupt requests to be dealt with by FIFO or priority method. The interrupt is managed by a separated segment of code determine what action should be taken for each type of interrupt. This part is called interrupt handler. There are regions in the kernel which must not be interrupted at all, like quick disk input-output, which includes read or write or input-output operations involving a physical disk. Interrupts can occur at any time, so the kernel tries to get it out of the way as soon as possible. The processor executes the interrupt by branching to a particular address in memory. The code at that address is called the interrupt handler. When the processor branches there, it masks interrupts and saves the contents of some registers in some place. The interrupt handler does what it must do, typically by communicating with the peripheral that triggered the interrupt to send or receive data. If the interrupt was raised by the timer, the handler might trigger the OS scheduler to switch to a different thread. When the handler finishes executing, it executes a special return from interrupt instruction that restores the saved registers and unmasks interrupts. It must run quickly because it's preventing any other interrupts from running. There are two types of interrupts: software interrupts and hardware interrupts. First, let we explain how the hardware inform for interrupt. An electronic signal sent from an external device or hardware to communicate with the processor, indicating that it requires immediate attention. For example, strokes from a keyboard or an action from a mouse invoke hardware interrupts, causing the CPU to read and process it. So, it arrives asynchronously and during any point of time while executing an instruction. Hardware interrupts are classified into two types. Maskable interrupts, in which processors have to interrupt mask register that allows enabling and disabling of hardware interrupts. Every signal has a bit placed in the mask register. If this bit is set, an interrupt is enabled and disabled when a bit is not set. Signals that interrupt the processors through these masks are referred to as masked interrupts. Non-maskable interrupts, which have the highest priority activities that need to be processed immediately and under any situation, such as a timeout signal generated from a watchdog timer. In software interrupt, the processor itself requests a software interrupt after executing certain instructions or if particular conditions are met. These can be a specific instruction that triggers an interrupt, such as subroutine calls, and can be triggered unexpectedly because of program execution errors, known as exceptions or traps.